only place in the world they can do that.
Only facility of its kind, and NASA actually uses this because if you think about it, when you're swimming underwater, you're in a near zero gravity environment, sort of like you would be in space.
You're isolated.
And you're isolated, and you have to be very careful to how you enter and leave the vehicle, and you're dependent on your equipment. So astronauts actually train here, plus you're in close quarters. The monks, as you saw earlier, pretty tight quarters.
Yeah.
For a couple of weeks, you better get along with each other.
That's right, sort of psychological testing along with everything else.
Now, one question people ask, Ellen, is how can you stay here so long? A normal scuba diver can only stay down for maybe 45 minutes or an hour, depending on the depth, and they have to exit and surface very, very slowly, or they get what's called the bends. How is it you avoid that here?
Well, here we like to sort of say, we just don't go up. Actually, we just prolong the issue of going to the surface. So basically what happens is after being underwater for 24 hours or more, your body becomes saturated with gas. We call it saturation diving. After that time, no matter what you do, you have to go through 17 hours of decompression, which just means very slowly coming up to the surface, releasing the gas that your body has absorbed.
When she says releasing the gas, she doesn't mean through flatulence. She means gas.
I wasn't going to say that.
She means gas bubbles that build up in your body, specifically a gas called nitrogen. If you're down deep levels, those bubbles compress. You know, if you ever blow bubbles at the bottom of a pool and watch how they expand, well, if you were diving and you dove up too fast, those bubbles would expand within your bloodstream and can cause strokes and very serious, well, they can be fatal.
So at the end of every mission, and let me say one other thing is that this is not just about the people inside Aquarius. There's a team of people that make this happen. We have 2 habitat technicians, experts that come down on every mission, and then there's actually a surface team, just like mission control at NASA. There's a surface team that is watching everything, life support, and they basically oversee decompression. So you go through 17 hours where you're slowly brought up to surface pressure while you're inside the habitat, and that's overseen by somebody who hasn't actually been living here.
Exactly. So there's a whole team supporting this, and that knowledge that we're gaining, it's not just, you may hear our voices may sound a little funny. That's because we're at 2.5 times the air pressure, and it affects how your vocal cords actually work. The way our bodies make sound is affected by being at this depth. Here's another question, Ellen. By the way, Ellen's got a wonderful new book coming up. What's the title of it?
It's going to make me... Well, the title is Sex, Drugs, and Sea Slime, the Ocean's Oddest Creatures and Why They Matter.
It's all about how animals or fish and other creatures in the ocean reproduce, survive with all sorts of amazing adaptations. It'll be out when? Next year?
In March. It'll be out in March, but what the fun part, I had so much fun. You really know,
I read the book.
I had so much fun writing this because I found just the craziest stories about creatures and then how they're connected to society. So I think people will really like it.
Well, some of it you read about it, and there might be an animal that when you read about it, you say, wow, that's disgusting, or it's yucky. But it turns out that something we thought was disgusting may actually produce medications or medicines that can cure or treat a number of very serious illnesses. Because these creatures out here have evolved over literally hundreds of millions of years to protect themselves, to reproduce, etc. And that learning that they've done over hundreds of millions of years, we can use that to help us produce medicines. Here's another question. How large is the research center? This is from Dalton at Napa Vine.
Maybe they're saying how large is the habitat? It's not very big, but it can house, every mission we house 6 people, 4 scientists and 2. I kind of like to think of it as a very large mobile home.
Yeah, that's good, isn't it?
It's about 43 feet long, 9 feet in diameter because it's a cylinder. But for 6 people, it's pretty comfortable. I mean, at the tour you saw people walking around. It's not too bad. Wouldn't want to put too many more than 6 people in here.
It's about the size of a large motorhome.
Yeah,
roughly.
Exactly.
The bunk, when you say 6 people, they're stacked up on 3 bunks and 3 bunks on top of it. They don't have their own room.
Right. It's not for claustrophobic people, but the key here is that if you're out diving 6 to 9 hours a day, you're actually only inside to eat, sleep, work on your data, maybe communicate. So it's not like you're in here the whole time. You're actually out diving most of the time, and that's what's so exciting.
Garrett and Brandy want to know how do we get oxygen down here? What is it that we're breathing? Because we're underwater after all.
That's a great question. Well, there's 2 ways. We actually have a compressor that sits on a buoy on the sea surface that's basically just hanging over the habitat, and that compressor creates air that's pumped down. We also have big flasks that sit on the seafloor of high pressure air that we can pump in as well.
You know, let me share with you why this matters to you and why it matters to Congress. I chair the committee that oversees energy and environment as part of our science committee. 68% of the Earth's surface is oceans, and yet we know very, very little about it. Scientists like Ellen and the other colleagues who research this know a tremendous amount, but they'd be the first to say that what we know is but a portion of what we need to know. 50% of the oxygen we breathe is produced by plankton in the ocean. All sorts of economic benefits. We mentioned medicinal benefits, and yet we know very little. Aquarius allows scientists to study this in a way nowhere else on Earth, and I'm really quite proud that our nation and our country has led this and proud to support this. And frankly, the costs of maintaining this facility are actually quite small relative to the grand budget and relative to what we learn about this.
Right, and what we can do with it.
Exactly. Now, one of the questions is, how much does a research lab cost?
Oh, how much does it cost? Well, surprisingly...
This is from Dalton, I think.
Yeah. You know, the lab was built many years ago, and so now our costs are just to operate it and have money. We actually give money out to scientists to come here. It sounds like a pretty good deal for most people. But so it's about maybe almost $2.5 million to operate. But then we like about another $500,000 to give out to scientists from other universities, actually across the world, who come here to use the lab.
From around the world, and NASA uses it.
And the Navy.
The U.S. Navy uses it because having divers in this environment for an extended period of time, you learn a great deal. You learn also how the human body functions at these greater depths and at these greater pressures.
Well, and it's great training in some of the techniques that both the Navy divers use and the astronauts use. For instance, sometimes they test some of their rovers and how do you build things underwater, and so they can stay here during rest and sleep, and then they go out and build things like they might build on the moon someday.
Right.
Or for the Navy divers, they may have to do it in some other capacity, but here they can train for some of those techniques, and they can't do it anywhere else.
Helen, what are some ways, if a young person's watching this, saying to themselves, boy, that's pretty cool, I'd like to learn to scuba dive, I'd like to one day be a marine biologist or a scientist who studies this, what are some things they could do to sort of do that? We'll have to leave in just a few minutes because we've got to surface pretty soon.
I know, unfortunately. Well, there's a number of things. Like almost any other field, it's following your interest and your passion and working hard. You can't become a marine scientist or biologist, geologist, whatever, thinking it's just going to come to you. Like anything else, you have to work hard, you have to go after opportunities. In high school, I used to be a lifeguard, and some of the guys I worked with brought a scuba tank to the pool, and they said, "You want to try this?" And I said, "Sure." Put the scuba tank on, and they're like, "Okay, come out of the pool now." I fell in love with it, and so I went to my parents and just said, "I want to get certified by myself." And then I started looking for opportunities to
certified is when you get a license that gets you, that you've taken certain safety training, says, okay, this person can be a diver. We've got more scuba divers swimming by right now.
So you can do things like get certified in scuba diving, go to local aquariums or nature centers, do volunteer work during the summers, be an intern somewhere, meet people who are doing the kind of jobs you're interested in. And the other thing is work hard in school. That sounds, everybody tells you to work hard, but it's really true. If you want to get ahead, particularly in science, you need to work hard in school, and then outside of that, look for opportunities to be engaged.
Give us an example of some of the most, from your book, I had the privilege of reading it. What are a couple of the most interesting things? You talked about what's a little snail that...
Cone snail.
The cone snail. Tell us a little about that, because I think students will find it tremendously interesting.
Cone snail is this incredible little shellfish, a little snail. The cone, guess what, they're all shaped like a cone. But it turns out that they have these harpoons that they use to basically prey on other organisms, and the harpoons are filled with venom.
So if I picked it up, I would die within... Well,
it depends.
Depends on
There's okay, it might hurt a little bit, and then the one nick and you're dead type. So one of the things is, if you're going to pick up a cone snail, you had better know what species it is.
Shouldn't you just ask your friends to this? Say, isn't that a beautiful...
Right. Well, and the ones that are the most deadly ones are the ones that they're cone snails that eat fish. And so they have to have the most deadly poison, because obviously fish could get away.
They have a deadly venom and a harpoon that injects.
And, and the harpoon has a tether on it, and that they essentially reel in, and they put the harpoon out, and they reel it in, and they eat it like
So a snail sits there, just looks passive, bam, out comes a harpoon,
Yep.
catches a fish.
reels it in, and then it has a snout like a snake that goes over its prey.
But now this venom that they use has real applications.
It does. The different species have different venoms, and in between their strikes, they can change their venom. Scientists are now looking at the cone snail venom and think that it has the most potential for pharmaceutical use of all the animal kingdom. These one little cone snails. There's a new non-opiate painkiller in the market called Creol that is derived from the cone snail. And so somebody who morphine might not work for them, or they might be, I met somebody who was allergic to morphine and was having horrible migraines, and she was so excited to learn that there was a new drug on the market that was not morphine based, and it came from the cone snail.
A very apparently humble little creature
That's right.
that actually has a deadly venom in nature that scientists are able to distill
Right.
and turn into a medicinal
And
use.
there are a lot of animals in the ocean that some we're looking for drugs, but a lot of animals that we use in biomedical research to use as models. You know, it might be, how does the nervous system work? They're studying the eyes of the lobsters, how the legs of the lobsters work. And so there are a lot of animals not only using to look for drugs, but to understand basic physiology.
Exactly.
It's really interesting.
Exactly. Well, we hope this has been interesting for you. We'll have this posted on our website in a couple of days, so you can share it with friends. If you look up Ellen Prager, she's got a host of research interests and publications. We wish you great success in school. We thank your teachers for linking you into this. We literally, I would normally say we have to run, but we're going to have to swim. We've been down a sufficient amount of time that if we don't leave fairly soon, we might suffer some ill consequences on surfacing.
Or have to stay a lot longer.
Having to stay would be okay. But thanks to all my friends and students out in the Pacific Northwest. It's really great to join you from a distance. I hope you've enjoyed this, and have a great day in school, and learn to love the oceans if you don't already. They are amazing places with extraordinary species and life, and we all depend on it. So that's why I'm so passionate about it. I know Ellen is. What you can't see here is there are several other crew members here helping maintain the vessel, and we want to thank them as well. Have a wonderful day. Thanks again to your teachers and your faculty. Study well, learn hard. Thanks very much.